Hey, what's up guys? Welcome back to my channel, and this video is going to be very good because this is a little bit advanced video, I would say, and this is going to be very crucial. I have been making a lot of Flutter videos for last many years, and now because I am sure that most of you have become already a Flutter developer, or you are learning to become even a better Flutter developer, or maybe you are working in a company already where you are building some projects. So this video could be very helpful for you. So today in this video we are going to talk about memory leaks, and to understand memory leaks we have to understand that how does it work, right? What kind of things we can do, how we can monitor memory leaks, how we can stop all these leaks, and how to use dev tools to do that. So if you are already interested in this particular topic, then don't forget to press the like button, and let's jump into the video. So as you can see on my screen, this is a normal Flutter application. This has nothing. Even in the pubspec.yml you won't find anything, because there's just a main dot file and main.dart file, and it just prints hello world. So to understand memory leak, okay, what we have to do, we have to, let's say we create a scenario that how actually all these things work, and how we can make our own memory leak detector. So what is memory leak basically is that start creating instances of your object which are not being removed by the garbage collector. So we can assume that let's do one thing. First of all, let's create a new file, and we can call it, let's say, memory leak.dart for now. We can definitely improve the naming and all. So there are couple of things, right? Say let's say that we go for a party, okay? So we are at the party. So now in the party there will be like 4 5 things, right? The first thing which would be there would be the venue of the party, right? Like let's say you are in Delhi, you want to go to a party which is somewhere at Chhatarpur. So that is the venue, right? And this venue is basically heap here in this case. So heap is basically the venue. Then there will be some guests in the party, right? So these guests are nothing but objects, okay? So basically in the party or in the heap there are objects, right, which are guests. And then there will be a third thing which will be root, or let's say host of the party, right? So that will be our root object, okay? And then the fourth one is none other than what, can you say? Bouncer. So there are bouncers in the party. So these bouncers are basically garbage collector. So what happens, let's say for that particular party, after a certain period of time, once you have completed the party or the timing is over, these bouncers job is to like remove these guests from the party or just throw them out, right? So that is what garbage collector does exactly with these objects. Once the need of those objects are over, or once those objects are not anymore required, this is the work of this garbage collector to throw them, right, or to remove them from the picture. So this is what we have to understand. Now to understand that, we will create this entire scenario. We will create how we can create our own memory leak detector. So let's jump into that. So first of all, I need a class called leakable object. So I'll just create a class called leakable object, as you can see over here. So this class has just a list of string with data, and as in constructor it just takes the data. So as you can see, class to hold memory leaking data. The second thing which I want is I want a memory entry. So memory entry class is basically, it will have a timestamp, and as well as all the tracked objects count, right? It's a map. Basically the key is a string and the count is basically a number. So these are the two classes, let's say, we require. Now what we are going to do, we will create a new class which we can say, let's say, memory leak detector. So this class will be our singleton class, where we will be doing a lot of stuff. So it is kind of Dart implementation of memory leak detection. So first of all, we have to make it singleton. So I'll just quickly create a singleton for it. So I'll just replace the class with this. Okay. So now you can see we have an instance. This is how you create singleton in Dart. Just to save some time, I'm just using some snippets which I just wrote. And now I need some variables to track all the objects, to monitor time, and for these memory entries. So I'll just use my variables. So here you can see we have a variable called tracked objects. Okay, it's a private variable. What does it do? It's basically a map which has a key as a string, and it has a set with weak references. All these weak references has a target. Okay, so we'll see that how does it work. Second thing is that we have a list of memory entries. This is the class which we created, where we will have a timestamp and the object count. And the third thing is monitoring timer, so that we can monitor everything. So this timer we can get from dart async library. So we'll just import it. And monitoring interval is right now 2 seconds. You can change it. And even the object count threshold is 1000. Again, you can change it as per your need. For the understanding, we are doing it. Now we have to create some functions or some methods for this class which can help us doing certain things. For example, we have to first of all start the monitoring process. So for that, we will be writing a function called start monitoring, where if the monitoring is already, or the timer is already running, we will cancel it. And the second thing is that if it is not running, then we will create a periodic timer with some interval, which is right now 2 seconds over here, if you can see. And we will keep checking the memory. Now this check memory does not exist as of now, but we will create it. Okay, and then we have a debug print that memory monitoring started. We can import, let's say, widgets dart just for the sake of it. So this check memory, like every time you are doing some monitoring, you have to check for the memory, that what is the status of the memory. So that is something which we have to create. We don't have it as of now, so let's create it. So let's say we have this check memory function. So check memory, what it does is basically it check for entry. So it creates a new entry, memory entry. It gives it the current time, date time dot count, and all the tracked object count. And this track object count we can get from this particular function, which we will again create, right? And once we have that, it will add it to memory entries. Let's say this memory entries file. Okay, so this file does not exist, or this I created actually. Oh, what is happening? Oh, this should be inside this. So let's just do that. Okay, so what it does, this entry it will add to this memory entries, and then it has to analyze that entry as well. So there is another function called analyze memory which we will create. Okay, and then the last thing is in this function is basically if the memory entries dot length gets greater than 100, then we remove one of the entries basically. So I mean, you can change the logic yourself. It does not has to be just like this, but this is just for understanding purposes, right? And now we need certain things. First of all, to get this tracked objects count, we should know how to track objects, right? So to track objects, what we can do, we can write a function called track objects. So what it will do, it will take an object and it will take a tag for it, like how you will identify which object is of which tag. So it will just check that we are doing it for three things for now, whether the object is a string, and this is checking right now whether the object is not string, and object is not number, and object is not boolean. Okay, if that is the case, then it uses this tracked objects. Again, this is the map which we created on the top, and it will, what it will do, it will put that particular object inside this map. So we are using put if absent, and the key is basically this tag. Okay, and this will be a weak reference, as you can see here that it is a set of weak reference. So this is what we will do. And there is another thing that we want to clean those tracked object using the tag. So for that also we can create a function called cleanup. So what cleanup will do, it will use the tracked objects map and use the key as tag and remove wherever there is a reference, and it will set the ref.target is equal to null. So if you will go inside weak reference, you will see that there is something called a target. Okay, you can read more about how does it work, but yeah, this is what you have to do. So now we have most of the things ready. One more thing is that I told you that we don't have something called get tracked object count. That is the first thing we don't have, and second is we don't have a way to analyze memory. So let's do that as well. Let's say get tracked count. So basically what it will do, it will have an empty map of counts, and then it will check for all tracked objects, and then it will first of all clean them, and then it will add them as well, so using the tag itself. So you will get the count from here. So this is, I mean, this is very simple logic. You don't have to do much to that. And once you have that, then we need something to analyze memory. So we have this function called analyze memory, where it takes a memory entry. It is first of all checking if the length is less than 2, then there is no point. So it will just return. Otherwise, it will first of all check for previous entry, and it can get by applying this logic that if the length it takes the memory entries and the index of that as memory length -2, which will give it the previous entry, and then it runs a loop throughout this tracked object counts, that what is the current count, what was the previous count, and if current count is actually greater than this object count threshold, or current count is greater than previous count, both of the things are valid, then it says that it might be a potential leak. So if you see this object count threshold, right now it is 1000. So as soon as this goes above 1000, this particular thing, like the object count threshold, like for example, if you create more than 1000 objects, then it will be treated as a potential leak. Okay, and with that there is another logic that your current count, right, should be greater than previous count, right? Otherwise it this logic won't work, right? And the second thing is that if this current entry, whatever entry you are giving to this analyze memory, okay, and if this current entry dot object count is not empty, then you will also calculate the growth rate. Okay, so how to calculate growth rate we will see, and how to calculate and maybe how to report this potential leak. So let's see how to calculate growth rate. So we can just use calc growth rate. So how does it work? It will first of all check if the memory entries length should be less than, if it is less than 10, it will directly return because there is no growth you can identify. So then if it is more than 10 or equal to 10, then it will check all the recent entries. As you can see, it just creates a sublist, and then it will check first count, last count, time span between them, because we are taking the timestamp of all this. And then once we have the difference, then it will check if time span is greater than 0. Then this is the formula of growth rate, that you will just do last count minus first count, and you will divide it by timestamp. And then if you have growth rate greater than 100, then you will say it is a high growth rate, right? That means the leaks are happening at a very high growth rate, right? That means it is very, very dangerous for your application. One thing is the potential leak, and second thing is that higher growth rate, right? Your objects are getting created like very rapidly. That is the growth rate basically here. So once you have all those things, so what we have to do, we have to create these two last functions, which is reporting for potential leak, and second is reporting high growth rate. So we can just say report leak. So this is report potential leak. This is basically just a print command where you will say that, okay, potential memory leak detected, where you will specify the tag, previous object count, current object count, and this is the growth total number of objects, right? And similarly for reporting growth, we will have another debug print where we will just use this growth rate, whatever we are passing, and that should be it, right? And we will just alert that high object growth rate detected. So this is all you have to create. Trust me, you don't have to do more than this. But yeah, I mean, this is itself a good thing to understand. And then obviously you don't have to create this. I'm just adding this to explain you that how this entire thing works. If you want, you can use this particular class. If you don't want to use this, you have the dev tools which gives you all of these things. Now one more thing which we need is, in the lib folder we will create a new file called memory mixin. So this mixin we can use with any widget, okay, any stateful widget, I would say. So what this mixin will do, so this mixin, let me just use my mixin. So as you can see, I'll just import material.dart, and what was the name of our class? Memory leak detector. So we will use this here. So this mixin is basically a very simple mixin, that is Dart memory leak detector mixin, which extends a stateful widget on a state class, and then it just creates a new object of this memory leak detector. And as you know that this memory leak detector is nothing but a singleton, and on init state it just start monitoring, and on this thing, like when the dispose function is called, it will just stop monitoring. And let's see if we have a function to stop monitoring. I don't think so we have. So let's create a function called stop monitoring. Yeah, nothing, but it will just cancel the timer, and it will just say that monitoring is stopped basically. So now you have the mixin. Now you can create any class, any stateful widget which will do the job for you. So for example, let's create a new file, and we can say memory leak widget dot. Okay, something like this. You can use anything, and I'm going to use a stateful widget. So I'll just say memory leak widget. You can name it anything. Now in the state class we can apply mixin using the with keyword, and we can just use our mixin, which is dart memory leak detector mixin. And as long as I add it, I'll just import this library, and that's all you have to do. Now to create this scenario that how memory leak will happen, so what we can do, again we can have a list of objects, the leakable object which we created, and we can have a timer, right? So what I can do is I can have these two things. One is the list of list of leakable object, and second is leakable timer. Okay, so what I will do, I will try to simulate the scenario, simulate memory leak. So how I can do that, I'll just write a function called simulate memory leak. Here I'll use this leaky timer. I will run it periodically after every millisecond. Okay, I mean you can change it to 100 millisecond, 10 millisecond, or 1 millisecond. And then I am adding, like I'm using set state. What I'm doing, I'm creating a new leakable object, and with every leakable object it generates 1000 fields, right? And all the items are called A for now. Okay, the name, like I mean the text is a string which is A, and then this leakable object item list, I am adding that leakable object. Now I am using this detector. If you see, right, this detector I get from this mixin, right? And if we go back to mixin, we can see we have a detector here, right? But rather than making it private, we can make it, let's say, public, so that we can use it anywhere. And now if I just remove this, now you can see I'm using detector.track object. Now what I'm doing is, this track object, as I said, it will take an object and a tag. So we are passing this object as leakable object. Again, this is a leakable object. This is not a string, this is not a number, this is not a boolean. So that is working for us, that logic. And then the tag we are giving is demo items, right? So this is all you have to do. And then there should be a mechanism, or there should be a button to stop all the leak, right? So we will create another function called stop leak, where we will just cancel the timer and we will just clear the items. And we will have a dispose function where we can cancel the timer again. And just in case we don't call stop leak and your application or this screen is disposed, or this screen is not used anymore, then this should not be leaking basically memory. So this is what we are doing. And now we have to just build a UI basically, where what we can do is we can show all these objects which are being created, and there should be a button to start the memory leak, stop the memory leak. And we also created one function which was let's see if I have created it. So there should be a function to get the memory report. Okay, we haven't created it. So what we will do, we will create another function called get memory report. We need a report also, right? So this function, what it will do, get memory report. If memory entries are empty, then it will just say that no memory data available. Otherwise it will take the last entry, it will create a string buffer, it will just write memory usage report, like just to give you nice log console thing. And then it will use the track object count to track the number of tag and count of that object. If the length of this memory entry is greater than 10, as we applied the same logic above as well, then we will say that growth rates last 10 measurements. And this is how we are just we are using the same logic we used on the top, and based on that we will just like have a report, like a lab report kind of thing. So now once we have that, let's build the UI. So we will just say leak UI, and what it will do, it has a scaffold, an app bar where it says memory leak monitor, and then it has a list view where there is a list tile which is just showing that item ka total length, what is the total length of item, and then it is using map to create list tile based on all these objects. And if it is greater than 10, then it just says that these many more items are also there. And then there are few buttons. One is to simulate memory leak, which is start memory leak. One is to stop memory leak and clear items, and the third one is to get memory report. So this is all you have to do. Now to get the best result, what ideally we should do, we should run it in a profile mode. Okay, that is very important. And then let's see how does it work, how it will show. And let me just choose Mac OS from here, because I am going to run it on a desktop, and let's run it and let's see how does it work. So once you run it, I'm sure that you will get a lot of good stuff kind of. And one more thing which I want to do is I want to also open DevTools at the same time to see that how this entire thing will look like, right? I mean, how it looks like in the existing thing. So you can see here, Flutter DevTools, Flutter tools, which says hello world. The reason is very simple, that in the main.dart we haven't replaced it with this memory leak widget. So we'll go to main.dart. I'll just replace this body, or maybe this entire home, with this memory leak widget. And maybe what we need is just a hot restart. So as you can see, currently it says objects tracked 0, and this is the button where we can say start memory leak. Also we have to see this console, because this is very important. Oh, okay, this console, I mean, let it be. This console will show us all the reports and everything. So what I should do now, let's create this, click on this button, start memory leak. So as soon as I click on it, you can see that how many objects are being created. And now like as soon as I did it, I can see that memory leak detected, because if you see the object count is greater than 1000, right? To demonstrate it better, what I should do is, let's do one thing, guys. Let's do this, let's go to the widget and let's do it 100 milliseconds first. So what I'm going to do, I'm going to stop this first of all, and let's do a restart. Okay, now it will happen slowly, so you will get the idea. So let's click on start memory leak. Now you'll see 1 2 3 4 and more items are being created, and now you can see we don't have any memory leak so far. So now if I click on this print memory report, if I click it here, then you can see that okay, tracked objects are just 104 objects, so it's still less than 1000, right? And we'll keep checking it. So rather than now, like we are trying to just do it slowly, that's why it is taking time to show us potential memory leak. Now what I'll do, I'll again stop it and I'll go back and I'll just say 1 millisecond, or let's do 1 second. 1 millisecond is fine. And now as long as I press this, you will see how many objects get tracked, like more than 1000 object, and now we see memory leak detected, and we'll see it again and again, right? And after some time, it will not just memory leak detected, it will also become that the high growth rate would be there. So let's see, after now you can see high object growth detected, right? So all these things you can see. Now let's do one thing, let's run it using DevTools. So what I'll do, I'll open DevTools in the browser, and I can go to, let me increase the font size maybe a little bit, and I can go to this memory tab, and I can see okay, all these things are happening here. Let's yeah, so you can see here in this particular thing that leakable object is there, right? And this leakable object, let me just zoom a little bit. You can see the instances of it is 32,716, which is a lot, and that is Dart heap size. You can already see 324 MB, which is just huge, right? and this is the usage, this is the capacity. And now if you click on refresh on GC, so every time garbage collection is happening, it will keep refreshing. But yeah, these are just very bad numbers, because this leakable object is part of singleton. So that is why this is still existing. The numbers are just increasing, it is not being removed from the memory. And as you can see, memory entry also, that is just now 45 instances are there, which is very very bad. And we can see everything in the console as well. You can also see the performance tab, and you will see that the performance will decrease after a while if it keeps happening. It won't be that great. And you can also track for widget builds. So I mean, this is what you can do. And I can show you a better example as well, that without, let's say, creating this custom leakable object, how you will identify. But yeah, this is how you identify. And what you can do is you can also see different snapshots. So you can record a particular thing for a while, you go to different screen, and you come back, and then if you stop it, you can have a difference of snapshots, that how it was looking before this screen was there, and how it is looking after that screen is over, right? Something like that. So now if I go back here, okay, so you can see main one, when I started taking the snapshot, was 558.6 MB. And now main 2, if I stop it, let's see what happens. So yeah, in the meantime that is being generated, we can go to VM tools here as well, and you can see the process memory as well, that how much memory is being used. And you can see the tree map as well. You can see all the objects here. And what I can do is I can go to my my app itself, Flutter tools, and I can see this main.dart, and I can I think I can click here and see the tree graph, but for some reason it's not working. Oh yeah, it's working. And you can see that this is what is happening. This is the class, all the things around this class. There are 3 things, like one leakable object, one is memory entry, and you can see currently allocated instances, which is around 65,000, which is a huge number. And I think, yeah, this could be a good information. You can see the details about the isolates. You can see the dart heap, which is just so bad, like right now at 617 MB. And yeah, you can see about the VM. Let's go back to memory. And this what is happening with this one? This is not stopping for some reason. But yeah, you can see different snapshots, and you can calculate it. I mean, it will give you a better result if you will have multiple screens. Right now I'm having only one screen, so I'm not checking whether the it is stopping or not. Let's say, for example, the dispose is happening or not. If you have listeners in your list, let's say scroll listener or something like that, if you don't dispose it properly, then you can see that how does it behave here. So all these things are a part of it. And yeah, this was slightly you can see there you can see that we can see this red line, which means that there are jank, there are slow frames. So that means the app is struggling a bit. And we have reached to 72,000, and growth has been very high. So yeah, I mean, let's stop it now, and you can print on the memory report, and you can see the memory report, which is nothing but how many track objects. Growth rate is almost 118.89 objects per second, which is it is very bad. I mean, in real life it will not be a good thing to have. So yeah, I mean, this is how you check memory leaks. And I hope you enjoyed this video. And if you need more details on real world implementation, that how things work in real world, we can take an example of an app. We can do certain things here and there, and we can see that how that app is doing things with memory. We can also take a look at CPU profiler. So if you want all of this, then let me know in the comments. And also don't forget to subscribe to the channel. Subscribe right now. And I am again back with a lot of videos regarding Flutter, app development and whatnot. So see you in the next one. Bye bye, take care.